Alright, so today is arithmetic and properties of real numbers. We're going to start by talking about what happens when we add two real numbers. First off, what happens when we have like signs. And what this means is they're either both positive or they're both negative. And so what we need to do is add the absolute value of the numbers and then use the common sign. So if they're both negative, we'll use a negative. If they're both positive, we'll use a positive. So for example, if we have 5 plus 6, well, that's just 11. They're both positive, our answer is positive. Next up, we have negative 3 plus negative 7. Well, 3 plus 7 is 10. They're both negative, so our 10 is negative also. When they have unlike signs, what this means is one is positive and the other one is negative. And so to do this, we subtract the absolute values and use the sign of the number with the larger absolute value. So for example, if we have negative 3 plus 7, we would do 7 minus 3 is 4. The 7 was positive, so our 4 is positive. Likewise, with 11 plus negative 20, we'll do 20 minus 11 is 9. But notice this 20 was negative, so our 9 is negative. When we subtract real numbers, the easiest thing to do this is just change it to adding the opposite. You don't always have to do that, but some people find it easier. So for example, if you have 4 minus 9, we can change this to 4 plus a negative 9. And now this is what we were just doing, so 9 minus 4 is 5. The 9 was negative, so our 5 is negative. For this middle one, we can change it to adding the opposite. The opposite of negative 13 is positive 13. And 12 plus 13 is 25. On this last one, it's the same idea. We'll have negative 18 plus the opposite of negative 20 is positive 20. Different signs, so we subtract. 20 minus 18 is 2. The 20 was positive, so our 2 is positive. Helpful idea to remember with these is anytime you have a minus a negative, so let's say you have 6 minus a negative 3, for example. When you add your opposites, these are going to cancel and make an addition. So anytime you have two negatives next to each other, it becomes addition, which would then just become 9. So that's an easy, helpful hint for remembering these. Now we've got fractions. First off, when we add or subtract, key thing is getting these common denominators. So for these first two, if we've got a 6 and a 9, our common denominator is going to be 18. You could use 36, or you could even use 54, but you're going to be dealing with larger numbers, and it's best to try to find the smallest number that both of them divide. So now this 5, 6, this negative 5, 6, think about what did you have to multiply the 6 by to get to 18? We had to multiply by 3. So we have to do that to our numerator as well. So we'll get negative 15. On the right side, we had to multiply this 9 by 2, which means we have to multiply the 7 by 2 as well to get to 14. And now that we've got common denominators, we only have to worry about our numerator. So we'll have negative 15 plus 14 is negative 1. On the right over here, notice the 7 is currently not written as a fraction, but we can change that by putting it over 1. Now our common denominator is just going to be 4. Notice the second fraction didn't change anything, so we can rewrite it. However, this one we had to multiply that denominator by 4, so we'll have to multiply the numerator as well. You get to 28 over 4. 28 minus 3 is 25 over 4. If you wanted to change this, to a mixed number and get 6 1/4, you can. To me, I don't care which one you use. However, I typically tend to leave it as improper, because it's fewer steps to make a mistake. Next up, we have multiplication and division of two real numbers. Two things to keep in mind. Multiplication, you will also see the word product. With division, you may also see the word quotient. When we have like signs, remember that they're both positive or they're both negative. Product's always going to be positive. So when you have 4 times 3, they're both positive. 4 times 3 is 12. Negative 12 divided by negative 12 is going to be a positive 1, because 12 divided by 12 is 1. Now, when unlike signs, remember this means one is positive and one is negative. And in this case, the product is always going to be negative. So for example, we have a negative 10 times a positive 5. So we know our answer is going to be negative. And then 10 times 5 is 50. Similarly, we have 24 divided by negative 8. Well, our answer is going to be negative because it's a positive divided by a negative. And 24 divided by 8 is 3. So negative 3. Notice anything times 0 is 0. So when you multiply by 0, the product is 0. But notice over here, you cannot divide by 0. It's undefined. A helpful mnemonic that I've had students teach me is it's okay for 0 to be divided by something, but it's not okay to divide by 0. So if your 0 is in the numerator, that's okay. However, if the 0 is in the denominator, you cannot do that. It's undefined. Alright, when we multiply, you want to multiply your numerators and denominators, but it's in your best interest to divide out common factors along the diagonal first. You'll just have smaller numbers to deal with, make it more manageable. So first off, when we look along this diagonal, we can take a 5 out of both of them. So 25 divided by 5 is 5. Negative 10 divided by 5 is negative 2. Along the other diagonal, we can divide a 3 out from both. So 9 divided by 3 is 3. 12 divided by 3 is 4. Now nothing else is going to divide out, so we now just multiply across. So negative 8 over 15. Key thing, once everything's divided out that can be, you just multiply across. When we divide, the easy way to do this is change the division to multiplication, and then you do the reciprocal, which just means flip the second fraction. So for example, in this first one, this negative 3 is over 1. So I'll have 45 over 28. Change the division to multiplication. And reciprocal means we're going to flip this second fraction, so it'll be 1 over negative 3. And now we'll use the same techniques we just did on the last page. And along the diagonal, 45 and negative 3, we can divide a 3 out from both. So negative 3 divided by 3 is negative 1. 45 divided by 3 is 15. Now multiply across, we'll get 15 over 28. And you always want to just double check, is there anything else that 15 and 28 will both can be divided by? No, so we're done. However, if you can, you want to keep reducing. This second one, same idea. This first fraction stays. Division becomes multiplication, and you flip the second fraction. What can we divide out? Well, we can take a 2 out here. Whoops. Into 1, and this becomes a 2. We divided a 2 out from both. Nothing else will divide. It's about 5 over 6. So now moving on to order of operations. First off, you always want to look at grouping symbols. So we're going to do this example on the right as we go through the order of operations. So first off, let's look grouping symbols. That would be these right here. So 5 minus 7 is negative 2, so we'll simplify that first. So this part is done. Grouping symbols we've taken care of. Now, exponents. We don't have any of those, so we're good for right now. Multiplication and division. Key thing here. Notice you want to go left to right. So in our case, going left to right, we'll have 3 times negative 2 is negative 6. Then we still have divided by 6 plus 3. But we still have a division here. So negative 6 divided by positive 6 is negative 1. And then we'll have our plus 3. So our multiplication and division is done. And so then last we've got addition and subtraction. Once again, left to right. So negative 1 plus 3 is 2. So you want to make sure you go left to right on both multiplication and division. So first off, we want to look at grouping symbols. There aren't any, so we don't have to worry about it. Same with exponents. Multiplication and division, left to right. So that means we've got 12 divided by 3 first, which is 4. We still have times 2. And now we still have multiplication and division, so we've got to continue to do that. 4 times 2 is 8. So notice you do want to go left to right. And now we're done. So notice this fraction bar is now actually being used as a grouping symbol. It's separating your numerator from your denominator. However, within our numerator, we also have another set of grouping symbols, 4 minus 6. So we'll have 5 minus 2 times 4 minus 6 is negative 2. No grouping symbols in the denominator, so we will just rewrite it. So grouping symbols done. Once again, no exponents. Multiplication. Now let's look. Going left to right in our numerator, we'll have 5 minus, and then 2 times negative 2 is negative 4. In our denominator, we'll have 2 times 3, so we'll have 9 minus 6. So multiplication and division is done now. Last but not least, we've got addition and subtraction. Notice, however, in our numerator, we have 5 minus a negative 4. We can change that to plus a positive 4. So in our numerator, we'll have 9. In our denominator, we've got 9 minus 6, which is 3. And 9 divided by 3 now is 3. So that's our answer. When we have x to the 6th, these exponents mean this x is getting multiplied by itself 6 times. So notice it's x times x times x times x times x times x. That's what this exponent means right here. It's getting multiplied by itself that many times. So we're going to start by writing these expressions without our exponents. So this first one just means it's 3 times 3 is 9, times 3 times 3. 9 times 3 is 27, times 3, so we'll get 81. So 3 to the 4th is 81. Now our next one, it's negative 3 to the 4th. Negative 3 times negative 3 is positive 9, times negative 3 times negative 3. 9 times negative 3 is negative 27, times negative 3. Negative 27 times negative 3 gets us back to positive 81. So if you've got a negative getting multiplied, you have to pay attention to whether our end answer is going to be negative or positive. This last one is different, because if you think back to order of operations, you want to have their exponents first after grouping. There's no grouping here. So this is actually negative 3 to the 4th, which is negative. We already did 3 to the 4th is 81. So I have negative 81. This negative is not getting the exponent. And that's because it's not in the parentheses like it was over here. Some properties and rules of exponents. We're going to be going a little fast on these. So this first one When you multiply your bases, you add your exponents. So when we add our exponents over here, we're going to get x to the 7 plus 5, which is 12. You have an exponent raised to a power, you want to multiply the exponents. So in our case, it's going to be h to the 36th power. When you have a product raised to an exponent, that exponent actually is going to go to both factors or all of the factors in there. So this quantity ab to the 5th is just a to the 5th, b to the 5th. And these are all just ways to simplify exponents. When you have a quotient raised to the exponent, it's the same idea as above. That exponent goes to both numerator and denominator. So this will be a to the 8th over b to the 8th. Next up is an easy one to remember. Anything to the 0 power is 1. So 7 to the 0 power is 1. When you divide bases, we subtract exponents. So for our example, this will be d to the 7th, because 10 minus 3 is 7. The last two go together. If you've got a negative exponent, it's moving to the denominator and then becomes positive. So in our case, this will be 1 over c to the 12th. And then this follows the same idea. If you've got a negative exponent in the denominator, it moves to the numerator and then becomes positive again. So notice we have g to the negative 3rd in our denominator. It gets moved to the numerator, which would just be over 1, which we don't have to write. So now let's simplify. These coefficients out front, we multiply like usual. They're numbers, they're not bases. So negative 8 times negative a half is positive 4. Half of 8 is 4. Our a's, we're multiplying them, so we want to add our exponents. So we'll have a to the 6th. This b doesn't have anybody to multiply by, so it's just times b. This next one, notice we have exponent raised to an exponent, so we multiply those, so it'll be b to the 12th. And then here, same idea, exponent raised to an exponent will multiply, that is b to the 14th. And now these two bases are getting multiplied, so we'll have b to the 12 plus 14, which is 26. Alright, now remember we've got a quotient raised to an exponent. The exponent goes to both of them. So this, we can think of it as a to the 5th cubed over b to the 7th cubed. And now we've got an exponent raised to an exponent. So we'll multiply the exponents. So a to the 15th over b to the 21st. And if you can skip this middle step here and go straight from here to here and multiply, that's fine. This middle step just helps clarify what exactly is going on. So this next one, once again, our bases are getting multiplied, so we want to add our exponents. Negative 7 plus 3 is negative 4. But now we've got a negative exponent, which means it'll be a to the positive 4 in our denominator. We've got an exponent raised to an exponent, so we'll multiply. So negative 5 times negative 3 is 15, so we'll have a to the 15th. So we've got exponent to an exponent, so we'll have a to the positive 6. In our denominator, we'll have a to the negative 6. And from here, there's really two ways you can do it. Since you see that this is a negative exponent down here, we can move it. So this a to the 6th will stay here. This one will come up and be a to the 6th because it's moved, so it becomes positive exponent. And now we add across our exponents in a to the 12th. Or from here, what we could have done was when we divide, we want to subtract our exponents. So we'd have a to the 6th minus a negative 6. And remember, when you have minus and negative, we add, which gets us to a to the 12th. So either way works, and it doesn't matter. You want to simplify what you can inside parentheses first. Remember, order of operations, do your grouping symbols. So in our parentheses, notice this a with a negative exponent, so it's going to move down, and our square is going to be positive. And notice our b's here, we want to subtract, so we'll actually have b to the 5 minus 8, which is b to the negative third. But we don't want this to be a negative exponent, so it'll be moved then to the denominator as well, which means we just have 1 left in our numerator. And then we still have this power of negative 3. Another way of thinking about this part right here is you have 8 b's in the denominator, 5 b's in your numerator. So 5 of them are going to cancel out with each other, and you'll have 3 left in your denominator because your denominator had more to begin with. Now, I'm going to just separate this so it's not confusing. Let's take care of this negative. And remember, a negative flips your fraction. So we'll have a squared b cubed in our numerator over 1, which doesn't do anything. Now to the positive 3 because we took care of that negative. And now this is like ones we've done before. You've got exponents being raised to an exponent, so we multiply. So a to the 6th, b to the 9th. This one looks confusing and complicated. Just take it piece by piece. So let's go ahead and get started. We're not even going to worry about this negative 2 out, an exponent. Let's first worry about this part. How can we simplify this? What can we take out of both? We can divide a 3 from both, and when we divide a 3, we're left with 4 in the denominator and 9 in our numerator. Now let's look at our a's. We have a cubed in the numerator and a to the 9th in the denominator. Notice 3 will cancel out. We're left with 6 in our denominator. Or if you subtract, you'd have a to the negative 6 and then move it. That's fine too. Looking at our b's, there's different ways you can do this. If you want to get rid of your negatives first, we can change it so that we have b to the 8th over b to the 5th, so that those negatives aren't there anymore. That's fine. These c's, notice we have c to the 7th over c to the 7th, and they'll just cancel each other out. Now, let's still worry about these b's. And remember, when you divide, you can subtract your exponents. So when we subtract our exponents, we'll have b cubed, and since that will be in your numerator. And then we still have all of this to the negative 2nd. Look at already how much easier this looks and how much more simple. Alright, so once again, this negative means we're going to flip our fraction. So we'll have 4a to the 6th over 9b cubed. Now it's just to the positive 2 because we took care of our negative. And now everything just gets squared. So I'll have 16a to the 12th over 81b to the 6th. So it's not too bad if we just take it piece by piece. Our t's, we can simplify. Remember, we subtract our exponents. So I'll have 2t to the n minus 3 all over 3. Now all of this is to the 5th power. So now everything is to the 5th power. 2 to the 5th power is 32. And let's take care of this 3 to the 5th power as well. That gives us 243. But now when we're going to have this t to the n minus 3, when we have an exponent raised to an exponent, we want to multiply our exponents. So we'll have that. But let's make this look nicer. So we'll have our 32 240 over 243 t to the 5n minus 15. To evaluate an expression given a specific value. So that means anywhere we see an a, we're going to use -4 because we want to know when a is negative 4. So we'll have negative 2. Instead of a, once again, we'll have negative 4. So we want to square it, minus 3. So negative 2, negative 4 squared, remember that's negative 4 times negative 4, which is 16, minus 3. Negative 2 times 16 is negative 32, minus 3. If you would like, you can add your negative, or negative 35. Alright, next up we've got properties. They are listed in your book. We aren't going to go through all of them here. The main one we're going to go through and talk about is the distributive property, and that's because we will use this one a lot. Notice here this a is getting multiplied to both parts. So we'll have a times b plus a times c. So for this first one, we're going to simplify. So notice this 5 is getting multiplied to both the x and that 7. So 5 times x is just 5x. And then 5 times this negative 7, or minus 5 times 7, is 35. On this second one, even though the negative 3 is on the right, this is still getting distributed to everything. So negative 3 times 2x is negative 6x. Negative 3 times 6 is negative 18, or minus 18. And negative 3 times negative 4m is positive 12m. Notice this negative is with that 4, so we can rewrite that as plus a negative 4m to help you see that it's a negative.